So one of the astronomical events that we can witness from Earth, at least if you're in the right part of the planet, is the aurora or the northern lights. But there's also the southern lights. They occur over the poles one way or another. And so we're going to start by looking at a couple of videos showing what the auroras look like. So we already studied the seasons, right? And the changing of the seasons and the cause of those different seasons. The next thing about Earth itself that we're going to look at is this aurora event. But of course, we have to watch an advertisement first, huh? So this first video shows the aurora, um, but really it's fast forward, it's time lapse. So the changes that you're going to see happening here aren't actually happening as fast as what this is showing. But this makes it look really cool. Sorry about the delay. Okay. So the aurora, it has these colored lights, and they look kind of like colorful clouds, but they're not clouds. This is atmosphere, this is molecules in the atmosphere glowing, releasing light in specific wavelengths, just like we saw in the lab of atomic spectra. Since there's a lot of nitrogen in the atmosphere, we have a lot of greens, and there's also a lot of oxygen, and that gives us these reds, and the different molecules release the different colors, just like we saw looking at those light bulbs with different gases in them. And so there's a stream of particles coming from the sun that they call the solar wind. And the solar wind excites those atoms in the upper atmosphere, just like we excited the atoms inside those light bulbs by turning on the electricity. And when they're excited, they gain energy, and then they fall back to their relaxed state, and they release light when they lose that energy. And that's the glow that we see here. But it turns out you pretty much have to be close to the poles, either to the North Pole or to the South Pole, in order to see these. So if we lived in Alaska, we'd be more likely to see them than we are here. Now this is kind of cool too. So if you look at this, shoot, I wanted to be right where we were. Sorry, having technical difficulties today. So they call a photo like this, you've probably seen it before, they call these star trails. And what they do is they take their camera and they just open up the lens. And as the planet is rotating, the stars appear to move across the sky. Now, if you're just standing there, these look like stars. But since this is a time exposure, you end up drawing a line with each of the stars. And what I want you to notice is there's one star in the middle of this, isn't there? And that star is the North Star, also called Polaris. It's directly above the North Pole. So as the planet is rotating, that star is right here. All the other stars seem to move around us, but that one stays right there. So if you know where Polaris is, you know that that's the direction to north if you drop a line straight down to the horizon. Here's another video. This one is more like the actual speed that we see the aurora. So they do move around. They kind of flow, and there might be some sort of slow motion flashing going on. To me, it looks like a curtain of light up in the sky. The edge of it's kind of waving there. So the first thing I'd like you to do on your assignment is just write down a reaction. Just respond to that. Leave this like that. So what do you think of that aurora anyway? Some people go way out of their way to see auroras. They'll take a trip to Alaska, and a big part of their trip is hoping to see this. But because it's kind of like weather, you don't know exactly if it's going to happen or not, or what day, or what time. It's a little risky. It's kind of like a good sunset. You don't always know exactly when you're going to get a good sunset, huh? But there's places in Alaska that have they sell rooms and cabins specifically so you can watch the aurora. I heard about this one place that has hot springs outside, so you can like soak in the hot spring while watching the aurora overhead, if one's happening, if you're lucky. I've been to Alaska a bunch of times because my dad lives there, and some of the hotels, they'll put your name on a list that if the aurora is visible, they'll call you and wake you up in the middle of the night to come look at it. But I haven't seen it yet. Okay, next. What makes this amazing light show? Oh, and by the way, that was all natural color, right? Was that obvious to you? That was the actual color of these things that we were looking at? It's because we're exciting the atoms, just like we did earlier. Okay, so here's a good definition of aurora and a comparison of the two types of auroras. So go ahead and use this information to answer that next question on your worksheet. Okay, so next what we're going to do is look at some different features of the atmosphere. And the atmosphere is divided into different layers. Um, so we're going to add to this, it's kind of a graph and it's kind of a diagram, a little of each. So the first thing we're going to do is we're going to draw a line at the ground surface. So I need to draw a line right where it says 0. I'm going to draw a line across there. This is to represent the ground. It doesn't really matter what color you use. So that's the surface of the Earth. That's where we're standing right now. And I also want you to notice that the scale on the left is in miles, miles above the surface. Now, the tallest mountain in the world is Mount Everest, and it's about 5 miles high. So I'm going to draw Mount Everest on here too, just to show how big it is. And the way I'm going to do that is I'm going to use the shapes. And if I had a triangle, I would just use the triangle, but I don't. So instead, I'm going to use this one called connected lines. And I think I'm going to zoom in a little bit to make this easier for me. Don't be too far. And to do the connected lines, you start just by clicking one spot, and then you click another spot. Now remember that this first line, can you tell that that's 10 miles high right there? Since this is 50, 40, 30, 20, 10, and 0, huh? Every line is 10 miles. The mountain is only 5 miles high, so I want to put it about halfway up. I'm going to click there, and then I'm going to click down here, and if I double click, my mountain will be done. So that's how I was able to draw a mountain, a triangle. Or you could just put two separate lines on there, would be another way to go. So that's the tallest mountain in the world. We're about 1 mile high right here at Incline, a little bit more than 1 mile. Everest is 5 miles high. The atmosphere is divided into several different layers. And the way that they found the layers was by sending balloons up high in the atmosphere, and mostly by measuring the temperature. You guys know that as you go uphill, it gets colder, right? As you go up in the atmosphere, it gets colder. Incline is colder than Reno, correct? Yeah, the higher you go on the mountain, the colder it is. That's why there's more snow up on top of Mount Rose than there is here, and more here than in Reno. But this only occurs to a certain point, and then it starts warming up again. And that's where they defined a new atmospheric layer. So this first layer, I think, was at 10 miles high. What I'm going to do is I'm just going to click on the line for the ground that I already drew, and I'm going to copy and paste that. The easy way to copy paste, I think, is to use the keyboard shortcuts. Hold the control button, hit the letter C to copy, or if you have a Mac, Command C, and then hold the control button and hit the letter V to paste it. So that's where we have a new atmospheric layer, and the pattern of cooling off reverses and it starts to warm up again. But then that pattern reverses again. And I believe that was at 30 miles high. So I'm going to paste that same layer again. And I'm going to put a line across at 30. And then it switches again. We have yet another layer at 50 miles high. So 0, 10, 30, and 50 each has its own layer. And then from 50, we jump all the way up to 300. This is a very thick layer. And once you get up to that 300 mark, you've basically left the Earth's atmosphere and you're now in outer space. Each of these layers has a name, and they all end with sphere. They're all parts of the atmosphere, but the bottom layer that we walk around in every day, we're going to label these names. This one's kind of hard to squeeze in there, so I'm going to put it off to the side, is the troposphere. The next layer up is probably the most familiar word to a lot of people of all the atmospheric layers. Most people don't know their names, but if they know any of the layer names, they know the stratosphere. That's where the ozone is found also. You might have heard of the ozone layer is part of the stratosphere. It protects us from the intense light of the sun, the ultraviolet light. Next, we have the mesosphere. Then we have this really thick layer called the thermosphere. It goes all the way from 50 to 300 miles above the Earth. And then once you've left the atmosphere, you're technically in outer space, and we call that the exosphere. And you can see the space station orbiting there. Uh, the diagram shows it about 250 miles up. Think about that for a minute. How long would it take you to drive 250 miles? That's basically from here to Sacramento, a little bit further. No, excuse me, that's from here to San Francisco, huh? So 4 or 5 hours maybe of driving, and you would be at the space station. So it's not that high above the planet, is it? But it's traveling like 17,000 miles an hour. Um, it's also really big and easy to see if it flies overhead. It orbits the Earth about once every hour and a half. And if you see it, it's got to be nighttime, but it's a bright light moving steadily and quickly across the sky. And at first you might think it's just a jet. But if it's a jet, if it's an airplane, then it'll have flashing lights on it. So if you're ever outside at night looking at the stars and you see what looks like a really bright star moving by and it's not flashing, then it's either a satellite or the space station. And then you've got some questions to answer. I just want you to use the diagram or graph, depending on how you think of it, to answer those questions. Name the layer, first of all, name the layer where meteors burn up. Then name the layer where we find weather. Weather does not occur throughout the entire atmosphere, only in one layer. Are there actually clouds and rain and fog and lightning and snowstorms? Only in one layer. Name that layer. Then label the layer where satellites orbit. Name the layer where jets fly. It's actually at the bottom of this layer. And then, of course, name the layer where we have auroras. Finally, on this page, you're going to compare how high an aurora is, its altitude. How high is the aurora compared to a cloud? How high is the aurora compared to a meteor? and tell me if that's what you expected or not. So I'm going to have you do these labels and then this question on your own. So take a minute to do those. So you got that okay? All right, let's go to the next page. And at this point, I'm going to have you work on your own, but I want to show you a couple things first. So you're going to go to this video and use it to answer questions. And this video is pretty short, but there's a ton of information in it. And that means that every 15, 20, 30 seconds, you've got another question to answer. So I highly advise you to pause the video a lot and even back it up if you need to. Notice right here, there's a little 1 minute mark on the worksheet. That means anything above this was before that 1 minute. Anything after was after that 1 minute mark. And by here, we're to the 2 minute mark, right? So use these to help you find the answers. Here's something else that I think might help. If you go to the video and you turn on CC down here, it will also write out the words that they're saying. And that might help. See how it's writing it? If I turn CC off, it doesn't show that anymore, huh? That stands for closed captioning. So this might help you if you turn on closed captioning, it might help you find stuff. It'll help you with spelling and all of that. Okay, so I'm going to give you, maybe half an hour to do this on your own. And then we're going to move on to another assignment. If you have any questions about anything on there, let me know. And I'll be happy to help, okay?